2.
Okay. So, I'm going to start on this one. I believe this is 18.
Oh.
So when we talked about yesterday, I thought we'd better talk about it today. I brought it up. I think I went through it in class yesterday because I was on the same boat you guys were when you brought it up. I looked at it and I didn't think I picked any weird ones. Well, this one seems weird because it's got e's on both sides. And what threw me off is if you try to take the natural log of both sides, this has a -5. You can't separate when there's subtraction. You can separate when they're multiplied together or divided. But you can't separate if there's a plus or minus side. And even if you move this 5 to the other side, you still have a plus or minus. The goofy part about doing this is that this e doesn't have a letter in it. It doesn't have a variable. And that's something I didn't catch at first. It doesn't even have a letter up there, so it doesn't matter. This is just a number. It is literally the natural number 2.7.
Well, it's to the first power.
Right? To the first power, right? So the idea is that what I would do first is move the 5 across, because you're just adding the natural number and 5 together. That's just a digit, right? It's a number. And on the other side, I have the 4e to the 2x minus 3. Now there's 2 different ways we can do this problem. I'm just going to show you my way of doing it. What I would do now that I'm here, I would just take the natural log of both sides. The reason being is that this side has an e in it. The other side is just a number. Now, if you wanted to divide the 4 over, you could do that. You could get the same answer. Question?
You said this was 18, right?
18.
Okay.
All right, so when I take the natural log of both sides, here's what I have. So natural log, the 4e to the 2x minus 3. Natural log e plus 5, and that's in parentheses over here. And this is in parentheses over here. Okay. So, now that I've taken the natural log of both sides, this side can separate, because these are being multiplied together. Those are being multiplied together. This side, I'm just going to leave it alone. That's just a number. It's just a digit, right? It's 2.71 plus 5. So that's just a number. It's a natural log of a digit, so I don't really care about it. Over here, separating. Natural log of 4 plus natural log e to the 2x minus 3. On this side, the natural log e plus 5. So I don't really need to do anything with that, because I can't separate. Those are being added together, so I can't separate them. Okay, still with me?
Kinda.
So all I've used so far is I've used the product rule. That's really what I've done so far. The product rule is when you have 2 things multiplied, you can separate them to plus. Now, what I need to do is solve for x. This 2x minus 3 will drop out front of this natural log, and then this natural log of e will just go away. It'll turn out to be a 1. This natural log of 4, I'm going to subtract it to the other side. So the answer I'm getting right now, I'm going to do this kind of in one quick swoop. This power is going to drop out front. I'm going to get rid of the natural log e, because technically this would be in a parenthesis with the natural log e behind it. But the natural log e is just the number 1, and 1 times anything is just itself. So I'm going to cancel out the natural log e. I'm going to subtract the natural log of 4 across the equality symbol, the equal sign. So I have that. That's where I'm currently at. Makes sense. 2 steps left. You add the 3 to the other side, divide by 2. You're done. That's your last 2 steps. So your final answer would be this whole mess, right? The whole mess with the 3 added on to it. We're going to add the 3 to the other side, and then you're going to divide everything by 2. And there's your final answer. You can leave it like that. I don't need to see the decimal or anything with that. Questions at all about number 18? Question?
You distribute the natural log to the e?
No. You don't distribute. That's not how that works. You just leave it. That's just the answer. Yep. You only need to like separate them if they're multiplied or divided. Yep. Good question. Yep. So if you didn't hear that, Drew asked, would you distribute the natural log? And no, that doesn't work that way. Nope. Okay. Questions? That's 18. Next one. This problem in particular used a property that was in the beginning of your homework. The first few problems of that assignment were just quick. Do you understand those basic properties of natural logs and logs, where things cancel out? Like on this problem, your goal is to solve for x. Well, on this problem in particular, they have an e and a log in its power. These two things literally cancel each other out because they're like inverses of each other. And so what you're left with here is x squared, the 1 and that 2x there. Like the x squared just drops out front. And now what I would do is I would do the factoring idea where I'd move the 2x and the negative 1 across. And I would factor these apart and I could figure out that this has 2 potential x's to it.
Wait, why did you take the 1 over?
I did. And 2x.
You did it so you could factor.
Yeah, I'm moving them to one side. Now why I'm doing that is because we have an x squared and an x in a number, so I have to factor. So when I factor this apart, we have, it's 2 parentheses, it's going to be x minus x and minus. They're the same symbol, they're both minus signs, it's 1 and 1. And so this actually only has one answer. It's positive 1, double root.
Genius, Mr. Ward.
Positive 1, double root. There you go. So it only has one answer, and you would have to go check to see if it works, and it should, in theory. Okay, questions at all about that type of problem? The reason I brought it up is because we have not discussed those simple properties since last Thursday or Friday. The simple properties with logs where like certain powers cancel each other out. It was like one of the first days we talked about all the weird properties you can do with
Boy,
logs.
this is so easy, dude.
Okay. Okay, last one. Last problem, and then I'm going to treat you loose in your homework. This one in particular, it's a story problem, and it talks about that you have a certain bacteria population that is growing, it's increasing. So you have certain bacteria that are infecting some type of population, and the bacteria are increasing by 3.3% per year. That's an increase of 3.3% per year. And the question is, can you write a formula that represents this bacteria growth? And what they want you to do is, and they even say in the instructions, use q to the 0, q sub 0, q sub naught, which is like the initial population. That's why they put it in terms of 0. This is the initial population of your bacteria. That's how I know it's the initial. It's at time of 0. They say, come up with a generic formula in terms of time and this initial population of bacteria using 3.3% growth. This is the easiest thing in the world. This is something we did literally 2 sections ago, where it was this. The amount of bacteria that are growing is equal to the initial population times your percent of growth. So I'm not using E, because they don't say it's growing exponentially. They say that they're growing by 3.3% per year. Well, that's this. That's 3.3% growth per year, constant growth. It's 100% plus 3% extra, and that's over a time of t or time of x. That's it. That's your whole property. If you wanted to know what your bacteria would be in year 2, you just put a 2 up here, and this formula would represent what would happen in year 2. If you wanted a 10, put a 10 here. If you knew what the initial population was, you could plug that in, and now you can find exact numbers. But they just wanted a generic formula, like what would represent this. The reason I bring this up is that every problem we've been doing has been exponentials, e's, and natural numbers, right? And this problem took you back a couple sections ago, and they just talked about what is like constant growth, not exponential growth. They're kind of one and the same. But it was just something I thought we'd better bring up. Questions at all about that problem? All right, I'm going to turn you loose. Page 33. It's due tomorrow. Have in mind, work on it. I'm going to hand back some papers tomorrow. You make fixes. So,
Take my book.
yes. I'll give you a pass. Yes, I'll give you a pass.
What do you write? Are you okay? What else?
So she turned it on. We have to wait.
Cross out and set.
You haven't done it yet.
Yes.
When's your birthday?
When?
December 1st. same one as my
December
mom's.
3rd?
Right around
Funny!
Christmas
So
time.
funny!
Her mom's December 4th.
My mom's December 1st.
My mom's in August.
No, it's the 3rd. It's
Oh,
the
is it
same
really
day.
the 3rd too?
As you and Mara too.
I remember she always brings up her, but I always didn't know if it's 3rd or 4th.
December 3rd, so ironic for today.
Hey, we're gonna meet over here? No, we're gonna meet.
Hey, how is this?
No, we're gonna
That's what do you got?
Hold on, I gotta put my feet there.
Why don't you?
That's
My mom's
No,
No.
Shit, Quizlet.
Oh.